Heights Elementary School. She is a phenomenal person. She took over the food bank just before the pandemic. The food bank was almost going underwater, financially in real tough shape. She pulled it through the pandemic, has increased, the load has increased to about 200 families a week to 1,000 families a week. She's an incredible person, and she'll do a great job next week. And then the 20th is Phil and Maury from the Bonnie Lake Senior Center, and they have some amazing things happening out there. And so we're off on a roll with our activities. Today we're going to hear about electric motors, electricity, and all the related functions related to automobiles.
Thank you. Thank you. My name is Ace here, and I'm a resident here. We've been here just about 3 years now, guys. And I am a retired naval officer and an engineer. I taught electrical engineering at the Naval Academy, and then years later I taught shortly after I retired down in Florida. Taught at Florida State and a small college there called Gulf Coast State College. And one of the courses I taught at Gulf Coast State College was I taught it for 2 semesters, a course on alternative energy. And I taught other courses there too that are all near and dear to me. But the emphasis on alternative energy was electric vehicles. So we built about 12 bicycles, and then we built a very hot motorcycle that scared me to death. This thing was, it had 2 huge electric motors inside the rear wheel. So there's no chain, no belt, and it was faster than you know what. And it was quite an experience. And then we built a Mazda Miata, and then we built it. And the Mazda Miata, you're familiar with those, is very small, very slow short, and it's a traditional 2-seater. It goes down corners real fast. It has a little motor. It's not really that fast as a racing car, but we took all the gasoline stuff out of it and put electric motors in it, and it was a race. It was very, very fast. We also built our Chevrolet S10 pickup trucks, small pickup truck. Took the bed completely off the truck and then put a whole bank of battery. That time we used lead acid batteries, never did that again. They were big and heavy and very slow, and that truck, if you step on the brake, it'll take 3 city blocks to try to stop. And it had some attributes, but not many. And I built a car for myself before all this started, which was an Acura Integra. I don't know if any of you familiar with that little car. Very cute little car. I bought it off a high school girl who was going off to college soon, and she thought, gee, this is a pretty old car. It was a 95, and this was about, 2012, was it, Sarah? Anyway, I lose all track of time. I bought that car from her for a fair price. She thought I was going to get old and be unreliable. I've never had an old car that ran so well. That car was absolutely approved like a kitten, and everything in the car worked. The rear window defroster was never working in the old car. The backup lights, the brakes, you name it. Everything about it. Remote locking and all that. And I remember feeling a guilty pang as I had it sitting outside at a auto hobby shop there at the local Navy base. Before I put it up on a lift and removed everything, they were just purring like a kid. What am I doing? And removed everything. It turns out the local folks there love to race those little cars, even though they have a very small engine. They're sporty and cute. So the guys were actually having fist fights. So we got to take it over. And I was worried that they get rid of it. Old mufflers, old fuel pump, old radiator, all that stuff. Engine. I kept the transmission, and I put an AC, 3-phase AC motor in it. And at the time, now it's very common. You see these all the time. But at the time, almost no one was doing this, so I had to kind of evolve this thing as it went along. I tried to design it like a good engineer. I had no idea what parts were available. Everything had to come from China. It was quite a challenge. Anyway, I drove that car for 3.5 years and had a lot of fun with it. And I became sort of a preacher, talking about the benefits of electric vehicles. And I just really liked the car. It was certainly not a Tesla. But the story about how I came, you might see that I wear a Tesla hat. And I'm not unbiased. I think the Tesla's a wonderful car, and now the good news is, where there are quite a few other cars on the road now. We've got at least a dozen to choose from now, and within a few months it's going to double that. So many of the automakers are finally coming around. They've been doing something one way for a long time. It's hard to change, but the advantages are just legion. And what most of that, I have another pitch that I've done before. In fact, there's one similar to it here. It talks about the history of the electric car. And I won't get into that in this talk. This talk is mostly comparing electric cars. One of them is a Honda pickup truck. It's called a Ridgeline, and it's a 2008, so it's not a youngster. And this is my Tesla with Sarah in it. Very close to the day we bought it. It was delivered to our driveway in early January 2016. It was built in October of 2015. And in late September of 2015 is when Tesla started to manufacture Autopilot. And we'll talk more about Autopilot in a minute. But I held off buying this thing until I could get an Autopilot. I'll go ahead and tell the story now because it's kind of fun. When I got the Autopilot and the car, I was just so excited. There was a supercharger, and that's what we Tesla people call gas station. And Tesla has actually, at their own expense, built a network of fueling stations all over the world. And there's 17,000 of them so far. Over 10,000 in this country. I think it's 12,000. Anybody know the number? It's hard to keep up with the changes so fast. Even just here in this Pacific Northwest, there's at least 25. So it's not as plentiful as gas stations, but it's rare that you go more than 100 miles at least in another Tesla charging station. All Teslas have a range over 200 miles, and some of them up to about 500 miles. So it is quite possible to drive cross country in a Tesla, and we've done it 5 times, coast to coast, and had a lot of fun. And in our case, we were one of the early adopters. We got the fuel for free. So whenever we stop and charge up, it doesn't cost us a nickel. That started getting pretty expensive, and we started making a lot of cars, so they changed the policy. And now you pay whatever the local rate is, but I will get to that in a minute. It's very inexpensive to pay for fuel for an electric car. It's about 3 cents a mile, and the IRS will reimburse you up to, what is it, 50 cents an hour? I forget what the number is, 42 cents. Anyway, it's a heck of a lot more than 3 cents a mile, because it costs you a lot more to get in the car. And we'll get to why that in a minute. But anyway, my car was brand new, and I was driving up. They had just built a Tesla supercharger up in Defuniak Spring, which is about 60 miles to the northwest. And to get there, you have to go up one highway and turn left on Highway 20. And well, when I first got the car, I couldn't get it to engage. Autopilot wouldn't do it. I've been reading about it. I'm so excited about getting the car to drive itself. So I called up the 24/7 hotline at Tesla and I said, I got this car delivered today, and it doesn't work. It's something lemon. I can't drive it on Autopilot. And he laughed and he said, wait till tomorrow. I said, what? He said, don't ask any more questions. When you get up in the morning, you'll be fine. Take a pill and call me in the morning. And it turns out what happens is one of the advantages of Tesla is that, and I don't know that other cars do this yet, but it's coming. When I park in my driveway, I can pick up Wi-Fi in my car. When I'm driving anywhere else, I pick up cell phone signals so I can get internet with a cell phone. So I just downloaded an upgrade and said, okay, now you've got Autopilot. So the next day I'm driving down Highway 20 to go to Defuniak Spring, and the speed limit is 55, and I can, it reads the speed limit sign with the camera. So it also has a database. It doesn't see a speed limit sign. It's very hard to be somewhere and use the claim to the officer. I didn't know what speed limit was, because you know it is all the time. And so does the Autopilot. So here we are driving along and engage it. It works like this. I can program it to go up to 5 miles an hour over the speed limit. Driving at 60 miles an hour on a 2-lane back road where the speed limit is 55. And man, this is horrible. I couldn't wait to tell my friends about it. And all of a sudden, it slowed down to 20 miles an hour. What in the world? And I said, what is that? And then I realized at the London, we had just passed the sign that said Highway 20. So, I was participating in one of these online chat sessions that guys who don't have anything else to do all day. And I shared my story. Somebody up in Delaware said, I'm going to go out and try it out on Highway 95. Anyway, my Honda is a 2008, and this is a 2015. Neither one's a new car. Okay? So to make this a fair comparison, I decided I would compare a 2021 Honda right off the showroom and a Tesla. And by the way, you don't buy a Tesla from my dealer. You buy it online. When I decided I wanted a Tesla, the guy that was showing me going under one, he was an engineer, not a salesman. I said, I want a red one, or all of this and that. He said, here's the web address. Go buy it, so I can learn how to email it. So now we're going to quickly learn some terminology, because to talk about electric cars, or talk about any cars, you have to kind of know what torque is, you have to know what horsepower is, you know what amps, volts, watts, kilowatt hours, and those are about all the terms you need. And I want to do this by way of it's a takeoff on something I tried at the Naval Academy I was teaching. I was teaching a course that was a real tough course. You guys flunked it right now. They're all scared to death of it. Because we had some guys that were English majors, and some guys, it's one of two universities in the country that requires electrical engineering of all students. And the other being West Point. So these guys are scared to death of this course that had a high funk algorithm and all this stuff. So I came up with a cute way to try to make these terms more understandable. And I'll try to use it here. There was a fellow named Galvani, Luigi Galvani, and he was a physician, a philosopher. Most guys in those days were a lot broader experience based than we have. Nowadays, when you're an engineer, they have a plan engineer. What's special within that? Everybody narrows down to one field and starts studying that way back when high school or something, which is kind of too bad. The whole idea of liberal is wrong. But anyway, this guy, Volta, was another guy. They were both Italians. Volta made what he called voltaic coils. All these guys were vain, and they wanted to have their name associated with something for the rest of that perpetuity. And so he made what he called voltaic coils by taking dissimilar metals and putting them close together, or in some cases, he put a liquid electrolyte, such as seawater or maybe acid, and put two kinds of metals in it, and then he could cause sparks to happen. He could make, if they hooked it up to a frog, he would jump, you know, or he could put it across his finger and he would jump. And so, these two guys were at almost the same time, right after around late 1780s. They were both experimenting with this thing that it was mysterious. Well, Volta was a chemist, and Luigi was religiously trained. So they had a different answer as to what it was. Galvani took frogs apart, and he could dissect their brains. And you know, the debate that he had is one that I've had myself. I took courses like this when I was in graduate school, and I specialized in what was called bioengineering, or we as electrical engineers. We had to take all the other courses needed for an electrical engineering degree, and then we started studying how the human body works from the point of view of electrical engineering. And one of the things that our professor explained to us is, I can take a section of your brain, and I can chemically analyze it, and I can actually build your brain by knowing what the chemical components are, but I can't put life in it. I can't make it have ideas. I can't make it initiate signals to go make my arm move or go convince somebody to buy an electric car. Those are things that happen inside my brain, and I can make the parts, but I can't breathe life into it. And so you can't help but have religious thoughts when you're doing this. And that's exactly what Galvani did. He concluded that he could take the sciatic nerve that comes down to your big, frogs have a huge thigh muscle. And so he would carve them open. We did this in the laboratory myself. And then we had the benefit of having modern test equipment, and we excited it with square wave, triangle wave, big boulders, little boulders. We tried all kinds of different frequencies and see what the quiver is, what the muscle did it, jump did it, let it did it. And so we're trying to analyze how electricity and the body works together. The Almighty concluded that this is God. It's God given. He called it animal electricity. And that's what causes all these things to happen. Alessandro Volta had a very different answer, and his answer was, it's the way chemicals work together. You know, if I can have chemicals and metals and whatnot, I can actually create something in the laboratory, and it works great. And it turns out they're both right, depending on your own religious view. And then this guy Coulomb said, well, what is it that's traveling down the wire when it causes spark to happen? And he, of course, he wanted his name associated with something for us life too. So he named the elemental charge, the unit of charge, the Coulomb. And so if you walk across the floor and touch a radiator, you'll draw a spark because you have built up a charge on your body, and you can cause a spark to occur. And so that's the Coulomb. And then this guy, a Frenchman named Ampere, and we call him Ampere nowadays, or amps. And Ampere was, what's it, mathematician, physicist, professor of history, professor of, I mean, come on, these guys are Renaissance man, a philosopher. And he said, well, if there's going to be coulombs of charge, and they go down a wire, and they cause something to happen like a spark, or they warm up a piece of metal or something at the end of the wire, then these coulombs must have flow. And so I'm going to call that flow amperes. So coulombs per second are amperes. So please remember this, because people get this all wrong all the time. Volts don't flow. We don't flow with voltage. Voltage is pressure. Voltage is what makes ampere flow. Is that clear? Yeah. Okay, make sure that's really well understood. Then this guy, Darcy Ball, came along, and he gave us a way to actually analyze how much current is flowing. He actually built a coil of wire through which the current would flow, and it would cause reflection of a meter. And that's, by the way, exactly how, if you have an analog meter, which nobody does anymore, if you have something that, with a meter that goes like this, it's a Darcy Ball movement. And so he was one of the first guys to do that. Now, if you look at this picture, we'll start with this picture here. Next guy, Oersted, somebody asked a minute ago, who invented this magnetic thing? You know, where did that come from? Oersted is over here, and he was a chemist and a physicist and all the other things. But he started thinking about, he had in the early days of sail, the navigators discovered, if you look at my little compass there, that in the early days of sail was called a lodestone. And they mounted it in a liquid. So it could rotate freely. And then they had it on a gimbal where as the ship did this, it would stay pretty much level. And they found that the Earth has lines of magnetic flux from north to south pole, or south to north pole, depending on how you study it. But the point is that as your ship turns, the lines of flux still go from south to north. And so the needle stays pointing to north, but it looks as though the needle's moving on the face as your ship turns. That's where as you turn. As a Navy guy, I remember training in helmsman. It was very hard for them to understand it. When I'm turning the wheel, that needle stays right where it is. The ship is turned, not the needle. Okay? So what he did was he was experimenting with wires and with coulombs of charge, amperes of current flowing, and volts causing it all to happen. The needle on his little lodestone starts to turn. And he said, wow, that's something. So he opined that if as a current comes down this wire, that's my thumb, and I curl my fingers around it, I have lines of magnetic flux going around the wire, and that is the basis of electromagnetics.
Right-hand rule. I mean, yeah.
Right-hand. Well,
yeah.
I have to take a light. I don't want to drag this out too long, but some people talk about the left-hand rule and current flowing from negative to positive. Others say current flows from positive to negative is the right-hand rule. They're both right. But you just have to take one. What's really odd is in the Navy, they teach the technicians, the enlisted guys who actually fix it. The other guys who don't know how it works. They teach them the left-hand rule, and they teach officers when they go off to college, they're the engineer, the right-hand rule. Go figure. That's the way, and when I took the ham radio exam, I was very amused to find they're using left-hand rules too. So they're more technicians than they are engineers. But the point is, if you take this wire and then wrap it in a coil, all right? Imagine this for just a second. I've got these lines coming off my first wire, and the second wire comes and they add. And the third wire and the fourth wire, so I got 3 times as much, the 3 wire. So if I have 1,000 wires, I have 1,000 times as much magnetism coming through the coil as I have with this one line. And that's how transformers work and that's how motors work. Is that quite clear? So this picture up here is a whole bunch of these wires, but see this, the little X as the convention means it's going into the phase. The little dot means it's coming out of the phase. So current's going into that wire, coming out of that wire, coming into that wire, out of that wire. So I have a coil of wires, just a 2D depiction of something that's happening pretty. And so anyway, that's how it all came together. And then James Watt, believe it or not, he was a mechanical engineer. Nowadays, a mechanical engineer, electrical engineer, they're like this, you know, it's like Virginia and West Virginia, Texas and Oklahoma, you know, they just not buddy. And here we have a mechanical engineer fiddling around with this stuff, and he came up with the idea, I want my name associated with something forever. So he came up with the idea of power. Now, to a physicist, power has a very exact meaning. And to an electrical engineer, power is a product of voltage and amperage. So just don't get too confused here, because you think it's a watt or a kilowatt means 1,000 watts. That's power, but not energy. And that's the place that everybody gets it wrong. When you get your electric bill, you don't pay for kilowatts of energy. You pay for kilowatt hours of energy. So if I ask you, if I hook a wire up to your toaster and I put a battery on it, and I make the coils glow red, let's say it's, I hook a 10-volt battery up to it, it's taking 1 ampere of current, and it gets red and cooks my toast. How many watts is that? That's 10 times 1, or 10 watts, okay? Or 0.01 kilowatts. My question is, how much does it cost? Depends on how long you leave it on, right? Okay? So you take a product of that 10, what did I say, 10 watts, and do it for 10 minutes at 1/6 of an hour. Let's use one simple number. 6 minutes, 10th of an hour, it's 1 kilowatt, 1 watt hour. Okay, 0.001 kilowatt hours. Did I get the numbers right? What do you get the idea? The product of power and time is energy. So here is the experiment. The guy that put this all together, of course, this isn't really the way it happened, but it's a good way to explain it. The guy that put it all together was a fellow named George Coleman. He was a German. It was pretty international. And these guys all read each other's papers. And he, by the way, was quite, well, I don't know if I put all this specialties up here, but he was a mathematician primarily. Anyway, what he did was, he took the voltaic coils of Mr. Volta that put together, and I showed 4 of them, 1, 2, 3, 4, and you could show up to 100 or 1,000, however much you have room on your lab table. And he hooked them up with wires, and then what he did was he got a galvanometer like we talked about, a little meter that goes this way and current goes with it, so you could tell how much current. And then he took hunks of stuff out of his desk drawer, he found an old pencil eraser. And he found that he put a whole lot of volts across that, almost no current. And they said, well, we took 2 voltaic coils, okay? 3, 4, 5, 10 voltaic coils, we still got, you know, just a tiny fraction of a milliamp, a millionth of a minute, that was a thousandth of a minute. Then he took a piece of silver, a wedding band, and put that in the same experiment. You know, just a tiny little bit, 1 voltaic coil on the current, so the meter's all the way off the scale, okay? So he then classified things. The first example is an insulator, and the second example is a conductor. So Ohm's law is very simply stated. He was a mathematician, and Carl will come to this real quickly. Get that one? The slope of this line is what determines the resistance. Okay, it's actually the inverse of slope. The voltage over the current. So if I throw a rise over the run, remember your high school algebra? We can look at the rise over the run. Here it's the run over the rise, it doesn't matter. The resistor is resistance, which he gave his own name, ohms. It is voltage divided by current. That's the way it was first announced. And it turns out that many things in nature are linear, which is kind of surprising. Because most of nature is not. Most of nature is sinusoidal. But it's quite interesting until along comes semiconductors. And that's you can see that it's both a conductor and a resistor. You know, an insulator. Because if you put a tiny bit of voltage across it, no current. A little bit more voltage, and then it shoots up straight up here. And that is a diode. And from a diode, you can get things like transistors and other things beyond that. And so it's not linear. And it has characteristics of both insulator and conductor, depending on what voltage is applied. So, we have now finished all the technical part of the discussion. We're now smart about all these terms. You know what a volt is? It's pressure that causes current to flow. You know what coulombs are? That's what makes up current. Coulombs are the element charge, and they flow down a conductor, and the number of them per second that flow is what an ampere is. A watt is a product of voltage and amperage, and it has real meaning to a physicist. And watt hours is how much energy we have used. And there was only one more thing I want to get across to you that all engineers think this way. You've probably heard the term black box. And so most engineers talk about all the components of, say, your television, a series of little black boxes. There's a little amplifier at the beginning that takes very weak signals coming off an antenna. It amplified it, and it goes into a mixer, and there's an oscillator. All these things have different names, and they're all called black boxes. So that's another way to. And here's a black box, so that's kind of a white box of it. But every black box is very important engineering terms. Has a consenta, and every black box has a causality. And now for the term efficiency, this is another word we use wrong all the time in everyday language. To a physicist or to an engineer, energy or efficiency is a very, very important concept. It takes how much energy you had coming into your device, and then how much energy comes out of the device. What does the device produce? You can't create energy. Another religious thing. Only God can create energy. So you can't make energy. You can only convert it. So this black box is often called a transducer. The name of the transducer is something that takes energy in one form and puts energy out in another form. Examples of a transducer, what about a light bulb? I've got electricity going in, and I've got light coming out. What else have I got going in? Heat, all right. And that's where this efficiency stuff is. This light bulb right here, I think, is incandescent. Terrible efficiency. It's probably 30% efficient. All that energy goes out as heat. How about your car? Think of all the ways it loses energy. When you're driving down the road, it's a series of explosions, a lot of explosions. And those explosions, you might not hear them much because they muffle them. And that, by the way, reduces efficiency when you muffle them. But that, what an automobile engine is, what they call ICE, internal combustion engine, what it is a pump. It sucks in air and pumps out dirty gas. That's how it works. And the process is a whole bunch of different conversions. If you take the amount of energy in a unit of gasoline, all right, and then take the amount of energy the car has going down the road, that's kinetic energy, 1/2 mv squared. Mass times velocity squared. That's the amount of energy. It took energy to get to that speed. It takes energy to maintain that speed. All right? But it's a heck of a lot more energy going into the engine than comes out into the wheels and makes the car move. Okay? So typical ICE, by the way, when you have several black boxes in a row, for example, if my engine is 20% efficient and my transmission is 90% efficient, then if we go from beginning to end, it's only 18%. It's the product of it. And since every one of them is less than one, you can't make perpetual motion. You can't make a machine more than 100% efficient. It just can't be done. So if you have a bunch of things going one after the other, every one is a number lower or smaller than one. It's a fraction. Therefore, the overall efficiency gets lower and lower and lower. I mean, how many things you do in a row? Is that clear? Okay. So the reason that the underlying reason why an electric car is better than a gasoline car is because the efficiency of an electric motor is typically 96%. It doesn't make a lot of heat, a little bit. It makes almost no noise, no friction. It's just a very, very efficient way to make electrical energy into something that rotates and moves. Okay? Gasoline engine, not so. In fact, it's astonishing that the gasoline engine or the diesel engine has come as far as it has. It's just there are something like 2,000 parts that all have to happen in just the right sequence, in the right amount, in the right timing, and everything else. So you turn your key and we all take it for granted, but it's a miracle every time it starts. There's a whole bucket of bolts, and they all have to do things in just the right order. The electric motor has one moving part. It's called the rotor. And in that motor right there that I passed around, it's something with a magnet with a compass nearby. That's an electric motor. The Tesla Model 3 that we're going to be talking about has a permanent magnet motor. It's better than my Tesla. I don't know what Tesla. And it has it's called an induction motor. It makes the magnetic field through magic. It's really bad. Tell stories about that. It's very, very hard to explain how it happens. But rotating magnet is easier to understand. If you can cause a magnetic field to rotate around what's called the stator, every electric motor has a fixed part and a rotating part. The stator, one is stationary, and then the rotor, which is the part that rotates. And so If you have a magnet inside and a rotating magnetic field, the magnet's going to turn, it's going to cause the shaft to turn, that can connect to the wheels and all fours off the wheel. So, electric motors, 96 to 99% typically. Gasoline engines, typically they're actually less than 20%. The very best that's ever been achieved is 27% that I'm aware of. So, here's the question. I'll go through this as quickly as I can. I just sat down thinking to myself, if I were trying to describe to somebody else, really much when I drove down here today, I brought my Tesla. So if anybody wants, I'll come out and demonstrate things like summon laws. You like to play with that one too, don't you think? Other things like that. Those are all things that, yeah, they're kind of cute and fun, but I just got to thinking, what do I like? I'd much rather drive my white car, my Tesla, than I would my pickup car.
没这个没什么太大意思，我看他讲这个，我记得才到。哦。
One of the things I like best, you probably haven't thought about this before. If you're driving a gasoline car,
没有很大的意思，
gas station again, you might think, oh, so what, big deal. Last time I went to the gas
对不
station,
对？
I had
那
to
不是那
park
个，
some of the other cars there. I had to.
不是一个 member， 不过他们
对，我知道，没很好，跟他是很好的东西
他会
啊。
费家里什么东西美或者什么随便什么，人都可以添加热情。
我们要不表上的度，
你也可以去讲，
排队，你要去排队，你说你在讲对，
哎，你会是
对啊，
也会跟那个
好，这不知道是哪一间房间，我知道哪一间房间哦。我看，我在那个大厅里面。
Go shopping and go find clean restaurants and people speak English and have a good time.
就很好啊，对啊，对啊，很好。我本那好像有8人来一，我要周周出来。
I'm not really an owner. I'm not saying I'm not a paying customer. I'm just charging my car invariably. Oh, when I go somewhere,
对，戴口罩。
join my TV show. Put your feet up. Want to read the
但
question?
是觉得有
It's a very good experience.
我没有多少可以明听着的。
I don't go to the gas station every when I get started in the morning, I've always got a full tank. I don't have to worry about it. Remember
对
the
他一定是台给台上，
对啊， 对啊，哼，7点半，9点告请妈帮我煮的，说，然后开车不给马，老开了。
Well,
Mhm.
sometimes it's every 6 weeks. But the changes are huge. On my dashboard, where it used to say drive, park, low, that moved. It goes over here. Holy mackerel, I'm not used to that. I'm still looking in the wrong place. And they make changes just like that happens on your computer. And they add features all the time. It's very, very, very. Right after I got my car, remember I'm living in Florida, so the temperature is typically 100 degrees and humidity is 90+%. And I'm sitting in the back row of church, kind of a boring sermon. And I'm sitting there and saying, man, when I get out of the car, I've got my coat and tie on, I'm going to be really hot and uncomfortable. Oh, there you go. I get out my little arm on my phone. They're on the air conditioner, they get 65 degrees. Sure enough, and I do that all the time. It has other features that you just don't take. You can't do that in your gasoline car because you have to start the engine. But with an electric motor, the motor actually stops. It doesn't idle, it stops. And so it has its air conditioner, and it actually has 2 heat pumps. One to keep the batteries happy and the other to keep them. And it's constantly juggling the temperature. So if you spend the night at a campsite and want to sleep in your car, you can turn on the air conditioner, or the heat, which you'll be on. And you can get up in the morning and you're perfectly comfortable. I can't do that without starting the engine. It has a summon mode. If I'm a woodworker and I like have lots of power tools and things in the garage, and if I've got a couple of vents on the side of my car where 2 by 4 would fall into it, they give us really small garages, so there's no grace. I can just push a button and the car just backs it out, stops in the driveway, and then when it comes in, I just hit the table saw and stops in just the right way. So it's a nice feature. The hold node, this is something I didn't even know about. I've been doing this for about 3 months. I hadn't read about it, I've never even heard people talk about it. But it's really nice. If I'm on a hill and I stop at a gas station, at a stoplight, if I let go of the brake, a little H comes on my dashboard for hold, and it just stays right there because my brakes are actuated electrically. Yours are actuated, if you have a gasoline car, hydraulic. And so it can't be done as easily. But in my car, I just sit there at it and I never drift. Even if I've been looking at my cell phone or daydreaming or whatever, the car never drifts around. By the way, the engine's not idling, so it doesn't drift for that reason. But it would drift if there were any incline on the hill. So when I push on the hold mode, it just stays. And all I got to do is touch either the brake or the throttle, and off she goes. Autopilot, more, but let me tell you real briefly what autopilot is. Now, Cadillac has it now, Nissan has a version of it. I think there's going to be lots of other cars that have it soon. And they're getting better all the time. In my car, if I pull back on the lever once, it'll go into cruise control, just like your car, but it has another little wrinkle. I have 8 sensors around my car, and the new ones have many more. I think it's 12. And I have a camera, a video camera, up in the front, another one in the rear. The modern ones, there are cars that came a year or two after me, they've got something like 8 cameras all around the car. And so they go in every direction. And if I'm, once I engage cruise control, I can then twist the lever and tell it how many car lengths I want to stay behind the guy in front of me. So if I want to drive 6 car lengths behind him on the highway, that's fine. When I get into heavy traffic, people start cutting me off and things like that and going slower, I can bring it up to 2 car lengths. So as the car in front of me stops, I stop. If he goes, I go. When I come to a stoplight, I don't have to touch anything. It's all. By the way, I can engage cruise control and I dead stop. So it's kind of fun. I'm at a stoplight and I want to have a conversation or something. All I got to do is pull it twice and it goes into cruise control. Autopilot. And then the car will just take off at the appropriate time. So that's a very nice feature. So there's 2 features. The second half, it not only keeps your distance constant from the guy in front of you, but it stays within the lane. Most of the vision, almost entirely visual. Mine is the earliest version, and it's nowhere near as nice as the new ones. New ones are called full self-driving, FSD. They are capable of full self-driving right now, and they're going to use several times, actually for long trips. But it's very hard to get the lawyers to allow, mainly because you can't figure out who to sue. If the car, you know, Tesla gets sued almost every single day. People claiming, oh, the autopilot made me do it. And what's really interesting is my car, and anybody who owns a Tesla, it phones home every couple of seconds. And it says, he's going this fast, he's at this location, he didn't touch the brake and he's on autopilot. So every time somebody claims, oh, the car made me do it, they come back, no, you were not on autopilot, you're going way too fast. They point out they win almost all the lawsuits. But imagine all the difficult things about self-driving. You come to a 4-way stop sign, who goes first? And we do a lot of this. Yeah, the cars can't do that. And now there's the next generation. I just read an investment newsletter just yesterday. And they suggested, here's the investment of the century. Here's what you need to do. Go out and buy a new Model 3 Tesla for $50,000. You got lots of extras. They start at $35,000. So you can get a $50,000 car with dual motors and all this other nice and really fast. So we got 0 to 60 in 3 point something seconds. And a really nice car, and then don't drive it. Huh? Why would I buy a $50,000 car and not drive it? In the morning, push the join the fleet button. And sure enough, your car will go out, and it will do like an Uber. It will go to 104 Elm Street, take a person over 27 Oak Street, and somehow they'll figure out how to pay for it, and it'll go on to the next guy. At the end of the day, they'll come back to the barn and charge it up in the morning. And in 1 year, you pay for your investment. Next year, it's all great. Now, that's a very good way of thinking about cars. The next thing is regenerative braking. Somebody mentioned that earlier. If you have a Toyota Prius, for example, or a Nissan Leaf, I think you have a Leaf.
Yeah.
You get at least regenerative braking, and I have it too. Even my home electric car has it, which is pretty cool. When you let go of the throttle, when you can develop a gasoline engine that does this for me out loud, when you start to slow down, it pumps fuel back into the tank. Okay, well, gasoline engines can't make fuel, so it's kind of hard to do that. One of my first experiences with this was when we were sitting around members of the hiking club here, and we took a couple of people in our back seat and we drove up to Mount Rainier, and I didn't start with a full tank for some reason. I forgot to charge the night before or something. We only had about 120 miles or something. Should have been plenty, it's only 40 miles to get up there or something. I got up there and I had almost nothing left. Going up that very steep hill, oh my gosh, I got people in the, my environment out there, but I got people counting really getting the coming back home, we were almost full. The monotonous charges, the motor becomes a generator. And sends energy back into the battery. That's what these hands all about. So I get used to driving my car, and when I let go of the throttle, it slows down. When I drive my other car, it just keeps going. Oh my God, I got stuff on the brake. So my brakes in my car ought to last forever. I don't do something. Okay, when it comes time to get your car serviced, you have to go in and get the oil changed. I don't have any oil to change. You have to get your timing belt fixed after 50,000 miles or something, 100,000 miles, whatever it is. Timing belt's a very big job. You got to take a whole engine apart. I don't have a timing belt. I don't have any lifters, and you got a whole list of things here. Catalytic converter, fuel pump, oil pump, valve, crankshaft, camshaft, lifters, sparker. I just noticed it came off the top of my head. There's 20 more that a typical automobile has that I don't have. Sure, car.
Okay, I gotta say, you're a salesman for Tesla because when you get a Leaf, you're not going to get all these features. It says why EVs. You're really talking about why Teslas because a Leaf does not have an autopilot.
I know, but Leaf is getting a lot better.
Yeah.
The Leaf is a darn good truck. I think they look kind of quirky. And when I was building my car, Leaf had just come out. And I invited a guy to come teach my class from the local Nissan dealer. And he said, I'll bring a Leaf out and I'll show them what a real production electric car will be. This is brand new at the time. Nobody ever seen one before. Well, when he got there, he was a sales guy. He was not a technical guy. When we put it up on the lift, we looked at it, it was just a pan with the whole car. Oh, good. And so we put it back down and we opened up the hood. What's that? I don't know. What's that? So it wasn't much of a demonstration. But I got a chance to drive that Leaf that day, and I got 4 ideas immediately on machine-man interface to how to make my car better. For example, when you step on the throttle, you use more energy. When you accelerate, well, I want to watch how much energy I'm using. On a gasoline engine, you use a vacuum gauge. If you step hard on the throttle, the vacuum drops off. I don't know if that means anything to anybody here. My boat costs a lot of money to operate gasoline engine. And I found out I could get up on step and move pretty fast at 3,200 RPM. When I went to 3,600 RPM, the vacuum went down to 0. The sucking fuel would go tomorrow, so I would drive my mind. So I did the same thing in my Leaf has a very good one. You can understand, the Toyota Prius is another one. In our class that we taught, someone had donated a wrecked Prius and they took the body away. There's nothing there but in fact, most of the gasoline stuff was gone. It was just the electric motor and it is remarkable. All those things going on, and it's reliable. I don't know why, because it's darn complicated. It's really a lot to it. So I learned a lot from them. I like Tesla a lot, but they're not the only one. There are a couple there. Some are saying they're even nicer. They're not production yet. Anyway, we come down to efficiency. The efficiency of my whole car is way, way better than this any gasoline. And I didn't start off with this, but a lot of people do. I'm not a tree hugger, I don't want to get into politics, global warming and all that. It's something we ought to be aware of, and we ought to be doing what we can about it. But that's not my major driver here. It's just efficiency. Okay, so let's compare the two cars. People say, aren't those electric cars really expensive? Well, that's exactly the same. Now, why did I pick those two? That's what I happen to own. You can pick almost any two cars. Yeah, you can find some electric cars that are very expensive, some that are pretty cheap. But I just took a sample to get off the top. Almost the same cost. But look at this. That Honda is pretty quick for a little pickup truck. 7 seconds to get 60 miles. 3.5. 4 or 5, depending which model you get. City, highway. 18 miles per gallon city. 24 miles per gallon highway. That's what EPA said. I got all these almost all out of almost the same one, Car and Driver magazine review of the car. So I trust them. I've been reading them since I was a kid. Now, we're going to talk about MPGE, and I've got lots of notes about it in case you'd like to go into more detail. But my car gets about 113 miles per gallon equivalent. I don't have any gallons at all. I can claim I get infinity miles per gallon. It's whatever miles I get divided by 0 is a very, very big number. I don't have any gas in it at all. if you convert the amount of energy in 1 gallon of gasoline into kilowatt hours, that number comes out 33.7. Yeah, 33.7 kilowatt hours per gallon of gasoline. So you can then convert my car to drive along the highway. I measure this all the time. It'll tell me not only average EPA and also instantaneous how many watt hours per mile am I using right now. Because I think about it a lot now, especially on a long trip. Like I may do it, you know. So I'd like to know how we're doing. And my car, on average, the EPA tells me, burns about 300 watt hours per mile, or 0.3 kilowatt hours per mile. I think your car is better. I don't even know. I can look it up. But I can then convert that into miles per gallon equivalent. Watt hours, make it into kilowatt hours. Take 100 gallons of gasoline, it would be equivalent to 100 kilowatt hours. And so I get about 113, but the Model 3 is considerably lighter than my car, 5,400 pounds. And this one is 3,800 pounds, 3,900 pounds. My car is 5,400 pounds. So I'm going to get a little lower MPGE. The Hyundai E6 just came out yesterday. It was a grand unveiling yesterday. Hyundai is now making an electric vehicle that gets 170 miles per gallon equivalent. So it's a lot better than your car with 20, 25, maybe even 30 if you have a really small peppy little car. The Honda Celier. The Honda is surprisingly powerful, 280 horsepower. It's a V6 engine. But this one, we don't talk about horsepower with electric cars because it doesn't have that much meaning. But it has a whole lot, and you can measure this a lot of different ways. This particular Model 3 has 2 motors, one in the front, one in the rear. So it's all-wheel drive constantly. And it's a 3-phase motor with a permanent magnet. And so you don't really add the horsepower of having 2 motors, but this is sort of an average between the two. It's a lot more than 480 horsepower. But where it really matters is torque, and we'll talk more about that in just a second. Now, Honda has a 4-speed automatic, so you go, okay, and we'll talk about why it does that. In my car, there's no transmission. My electric motor is perfectly happy at 0 RPM, and it's just as happy at 18,000 RPM. So that gets me from 0 to 140 miles an hour. No reason to ever feel it. So I don't even have a low range on my shift, my transmission. Yeah, it's just drive and park and reverse. And by the way, when you're in reverse, in your car, you have to put another gear in the transmission to make it run backwards. In my car, the motor runs backwards. So my car is perfectly happy when one direction or the other. It just depends on which way the magnetic field is. And that's easy, just put the whole there. Okay, and the warranty is a little better in the Tesla. It's 8 years on batteries and motors and controllers and things. 4-year pump bumper. Brand new Honda will come with 3 years, but they specify now, and the Tesla does not. So here's the discussion of what is torque. Have you ever tried to turn a bolt with a wrench, and you find that, well, if the wrench is this long, I can turn it a lot harder. Okay? That's the concept of torque. It's units of foot-pounds if we use the English system. I really think we ought to switch over and use the American system, like every other country in the entire world. And I can tell you a very recent story of how this has really been hard for me. But nevertheless, the number of pounds of force multiplied by the distance away from the fulcrum is the amount of torque one gets. And that's what matters. Torque is what drives your car. And so, why does the guy at the gas at the stoplight races in? Why does he do that? My car just sits there stopped, and I don't want to race it. If I go to the drag race, my car is totally inoperable. When I start, when the light turns green, I stop it. And these guys are up real high before he goes. Why is that? Because his torque doesn't happen until about 5,000 RPM. There's no issue to that. Okay? My maximum torque is at 0 RPM. And that's another inherent advantage of electric motor. In fact, if there's one reason that you would power your car electrically rather than gasoline, that's it. That efficiency. Okay? So the torque of an electric engine is very, very high. It's much higher than it ever gets in a gasoline engine. And It does fall off at higher RPM. I'm up around 16,000 RPM. My speed to get from 120 to 140 is not really all that great, but I don't drive that fast. I don't think it hurt. So to me, it's just fun. And people have known this for years. Electric, locomotives, the whole big trains, tugboats, even big ocean liners are very often driven by electric motors. You have a diesel engine that drives a generator which provides electricity. Each one of those, I think those black boxes, one after the other, each one has an efficiency. So the electric motor part is very efficient. Okay? And the reason I do that is because you get real high torque available. Is that very much so? The Tesla, the Model 3, 503 foot-pounds in one motor, 531 have it. You don't add those up. I can't claim it 1,000 foot-pounds of torque. It's more complicated than that. But it's a heck of a lot more than 500. And the Honda has 262. So that's the difference. That's why when I give it a stoplight, there are very few people who pass me, if I remember the reason. Okay, so here's what's available. You want to go out and buy a car right now? And I left a few off. I was just cruising all over the internet trying to find out what's available. Up until just a few minutes ago, late yesterday, a Hummer, and now it's electric for you can imagine that. Mustang came out with a Lockheed about a month ago, and they've been filling the air with advertising. The reviews are mixed. If you're a Mustang fan, I'm sorry, they're really sick looking at it. Kind of weird ass. Anyway, it's not going to help. Chevy Bolt's a good car. I really like a Chevy Bolt, and it turns in very good numbers. There's some things about it that are not ideal, but I think in a few years it's going to get. I don't know why it takes General Motors and Ford so long to decide. I think Chevy just announced that we're going to be all electric by 2035 or something. That's not good. The way Tesla started from the ground up, it's going to be an electric car from day one. That's all we're going to do. And I think it's a good Audi e-tron, I've not driven them. I've seen them, and they're pretty cool. Really nice. The Hyundai and the Kia are closely related. They're almost like BMW and Mercedes. I think one owns part of the other or something. Their models are quite similar. But they're getting very, very good reviews, especially the one called EV6, electric vehicle 6, made by Kia. That's this one. A little Cooper, a little squished up, used to be British, I guess it's German now. They have one that's electric. Mitsubishi was one of the early ones. It's no longer available. You can buy it now, use it. So these are all electric. Volvo's really had a big commitment to electric. They're making a full start. We went to Singapore about 2 years ago, and they were common at it. We got a lot of wealth there. And people were driving, and I couldn't help but notice the cars going by. The Jaguar I-Pace is one beautiful car. And it's all electric, and it is fast and sure. And of course, I can't same thing. They can't stand the idea that Tesla can still beat them. And it's happening regularly because they're always the racing capital of the world. And it won't be long before they beat Tesla. I haven't in the practice. Tesla has a number of models. You notice anything funny about the model numbers? Elon Musk he's not and he actually planned to make a second car, the Model E, and then Ford patented the name. Can't remember the name. It's a legal process, but on the name. So Ford heard about that, so Elon being a clever guy here, we'll just make it three and leave the side two so it looks like he. So he's made this very successful. Volkswagen is really good. They had the big trouble with what they call Dieselgate, and they are trying to dig themselves out from that, so they committed themselves fully to electric. And I just read a review of the ID4, which is the newest one. I think it's available in this country now. It's been in Europe for a little while. It's getting very, very good. These are the ones that are coming out soon. My son-in-law has a BMW i3, which, and he's 6'6", and he gets into this little car very comfortably. It's really surprising. The only problem with that BMW that I can see is it's only good for 80 miles. And that's my problem with the Leaf up until the federation. But now they're over 200. So, and the new BMW i4 is they have an X2, which is a little smooth. Cadillac River, that's going to be really good. It's a real one. Not much to say about most of these. Now, pickup, that's another whole, that's the hottest selling thing. I don't know. Pickup, so I think GM sells more Chevy Silverados and Ford sells the F-150 and so forth. And they've got an electric version coming out soon. It's all on, it's going to be really nice. But the Tesla Cybertruck, maybe you've seen pictures of it. If you look at the picture, it's not for everybody. You have to look like a spaceship. But it is unbelievably powerful. It goes 100 miles on one charge. Stainless steel, and it's, I don't want to get in the way of all this. The Rivian is one I got my eye on. That's very, very nice. Has a lot of features, and it's very close to release. We're right now. I haven't talked about the 18-wheelers. There's several of those. So the bottom line, there are some advantages to an electric vehicle over ICE, and I listed what they are here. But let's start with what the ICE vehicle, the internal combustion engine car. What's it got that the electric cars don't have? Well, they've got years and years of production experience. That's what they've been doing from the very beginning. But interestingly, like I mentioned earlier, if you look into the history of electric vehicles, they way preceded gasoline vehicles. When the first electric motor was invented in the late 1700s, early 1800s, the very first application anybody thought to put into was put them on a board used to be hauled by a horse. A horseless carriage. They got figures like 4 miles per hour and maybe 8 miles of range, And we would all be driving electric cars from that way back then to Henry Ford had to go on. They wanted it a lot cheaper. The Tin Lizzie with Model T. And they had a gasoline. There's a lot of politics involved in that. But the thing is, if you have a gasoline car, you can go further on tank and you can fill it up in 5 minutes. It takes me about 20 minutes, typically, on the road. You have a fueling infrastructure on foot. A gas station on every corner. I'm not there yet, but I'm looking for lots of experience. But where are the advantages for the EVs? Well, have a lot more acceleration, power and torque, efficiency off the dumpstone site. It costs me very, very little. I have a solar on my house, and I'm using only a fraction of what my solar generates for all my driving, and the rest tends to lower the cost of the electric bill. So my electric bill is close to zero, and I get to drive for free. And then when I'm on the road, since I bought an early version, I can use superchargers to charge my car for free. But even if you charge at the prevailing rate, especially here in Northwest, Pacific Northwest, our kilowatt hour rate is about 9.8 cents. It's going to go up soon. But that's one of the best in the country. And when you work that out, that's how I ended up with about 2.9 cents per mile. So cheaper to operate, way fewer things to go wrong. I've got a door handle fail. My trunk, it's an electric motor, lifts it and it comes back and it doesn't want to latch. I have to push it. That's a pretty minor problem as far as I'm concerned. I've had to replace the wiper blades once and the tires twice. And I have 100,000 miles. That's it. So it's kind of hard to beat. I've never changed the oil. My warranty is good. Of course, I'm way beyond my 4-year warranty, but I'm not that worried about it. I charge it home every night. All it takes is it looks like a dryer plug. It's a NEMA 1850 plug. And it's the first thing I did when I moved into the garage. I installed it myself and cost about $40 in parts. And that's what I use every night.
Is that the same plug for anybody else, or is that a different one? But is the Tesla plug unique, or is it?
Yeah, it's the same plug I use every night. And I've been reading a lot online, people who live in this area. I can't believe it this costs money. I moved here from Florida. An electrician will charge about $2,500 in solar. It cost me $40. Online upgrades, we talked about that. If I'm in a motel at night, I do it over the cell phone. It's better to do it with the Wi-Fi station. Anybody who's ridden with me in my car, a couple of you have, it's incredibly quiet. And it's very smooth. There's never any shifting. There's no passing gear. If I'm driving along and I pass somebody, stomping, And there's a lot of features that I didn't think about. I thought about 2 or 3 others that I walked away from. And we had that big snowstorm up here, or not this past one, but the winter before. We were new to this area, coming from Florida, snow was kind of a big deal. And we had already made reservations for a week at the beach in Oregon. And so, man, I didn't really want to drive in all the snow, and it's a garden to handle it. And what I found is an electric vehicle, and I don't know if Leaf does this, but it has very sensitive electronics to keep your wheels. You cannot, when you see a guy stuck in a slow line, with the wheel beginning, you can't do that. It won't let you. When you're at the drag race, and you've got 500 some odd horsepower, all that torque, you stomp on it, the wheels never spin. Because if it detects a little bit of slippage, it backs off on the pedal. And so I found that I could drive, even though I've only got rear-wheel drive, so I was good. I could drive through the snow no problem, which is really something that I never really thought about. So, in conclusion, I do have a bias. I'm very enthusiastic, but I tried to make a fair comparison and try to get the good warts and the pimples and all the good stuff and the bad stuff at the same time. I believe that the internal combustion engine it's just incredibly complex now. It's gotten very, very reliable, and you can count on it for many years of good service. So it's come a long way, but it can't come much further. It's inherently inferior. It's simple to do. And so when you're an engineer, and no matter what kind of engineer, aeronautical, naval architect, electrical, whatever, you talk efficiency. Wow. How much energy does it take to do such and such? And how can I lower the amount of loss to the heat and so on? That's my presentation to you all. Well, I have any questions about it. You want to go through it? Please.
But you have a question?
The Tesla Model 3 stop before red lights and stop sign?
It does, to my knowledge.
Really?
Well, mine will recognize red lights and regular stop signs, and it'll just go right through the lawyers won't let them know. The Model 3 has full self-driving, and
I have that.
yeah, you have full self-driving.
Yeah, I must stop.
As to whether you can implement it now, I don't know for sure. I've got mixed signals on that. I read about this stuff almost every day. And matter of fact, forward, let's see if I can.
Yeah. About 1 month ago, my car recognized lights. I can see on screen the lights, green, red.
Yeah,
but it does stop.
it doesn't stop.
No.
Well, I don't know whether you can make an adjustment, put a setting into it or not, but I bet you could estimate that. Are you in the Tesla user group that talks every day on the internet? There's a bunch of them. That's a topic that asks some of the guys that really know. Because there's some people that look at Tesla and answer questions too.
Okay.
I wanted to show you real quick one way to deal with this. I took off my glasses so I don't fog up. Of course, you can't have it operating like that. If I stop the slideshow, where's the stop slideshow? Slideshow, when we do the world. I'm going to waste your time. I can do this with a minute. I have all set up here on the internet. The report that you can get for free, and I get a bunch of them. One is called Green Car Reports. And I looked at it just yesterday so I could be current, because by the time I finished talking about this subject in 1 hour, everything's changed. It's a fast-moving field. Well, this morning when I was setting up to get ready for you guys, I brought up Green Car Reports. And sure enough, there were 5 new things, and there were a couple of cars on there that I haven't even had on my list of what's available. And there's reviews of them and how they're doing and stuff like that. I really recommend it. If you have any interest in the subject, there's lots and lots of them. That's just one Green Car Reports on one of them. Any other questions? Yeah.
Yeah, when you first, one of the first slides you put up compared the efficiencies.
Yeah.
And You know, it doesn't take into account the efficiency of taking petroleum, hydrocarbon fuel and creating
But
electricity.
I have whatever, but I have looked at that. I have looked at that, and it's still, yes, it takes even more energy. I mean, if you go all the way back to the elemental stuff, what came out of the ground, how much energy did it take to pump it, to clean it, to refine it, to truck it down the road, to put it in the gas, it makes it even more compelling story. Although electricity, you got the same argument. I got natural gas, and I've got black oil, or diesel oil, and I've got hydroelectric, and I've got solar, all these different things coming in. Hey, electricity, but every one of them costs money and has efficiency. My solar, that's a very good point. My solar panels, I got the latest and greatest it has of about 2 years ago, and they're all the way up to 22% efficient. So that's a very good example. If you want to look at the whole efficiency picture, it's not so good, because you have to multiply each one of those efficiencies. And if you have 22% out of your solar panels, and then 96% in your car, you end up with, what, 20% overall efficiency. Not very good. Very good point. Anything else? Oh, you got the car.
Okay, we didn't talk about taxes.
Factory?
Taxes, electric vehicles, tax costs a lot more. TAX, tax.
TAX?
Yeah.
Yeah,
And,
my license plates this year cost me $850.
Yeah.
That stinks. It cost me $20
yeah, but,
Well, taxes are something I told you I wouldn't bet on.
and,
I don't want to get through.
okay, no, it costs a lot more to get your tabs for,
That's true, but then look at,
because of the taxation situation.
what's the cost per gallon in Texas? Anybody know? I used to know. 49 cents or something, out of the
At
3
least, at least.
It's very high. And here it's higher than most places in California.
Yeah,
Now, we're getting into politics.
yeah,
Well, bottom line is you gotta pay for the rules somewhere.
yeah, that's right.
Yes, okay. Okay. We're going to get involved, okay? All this infrastructure we're talking about at national level should be going to state level. You know, we got a big bill coming, trillions and trillions of dollars. Only a small fraction of that, maybe less than 20%, has anything to do with roads and bridges. It all goes to other things. And so we do lost on it. But my question is, why don't they just say, those roads are handled by state and local governments, they should pay for it. Now, how they get the money to pay for it, that's a problem. I don't want to run for office, I don't want to tell them they can increase the tax. So the way I do it is I can wait, when I tell them, we won't get it.
We're talking about a million mile battery.
There's a lot of work going on. If there's one long, this one is shown cities. If there's, in fact, there are two things I mentioned both of them. If you're a young guy just getting started off in the world of engineering, where are you going to make your big money? One of them is efficiency of solar panels. We've got to get better than 30% something. And the other is battery technology. And there are legions of people working on batteries. I read about one day before yesterday. It's a combination of lithium and air. More than we does than that. And it's got marvelous energy density. Meaning I can get a lot of kilowatt hours out of a very small package. And it's inexpensive. And everything except for one little problem. When they try to use it, it won't charge. So you can discharge it just great. It's like an album. And there's claims coming out almost every day about it. I got one that can go through. About a week ago, I was reading about what they call cycles, charge cycles. How many times can you charge battery? Only up to dischargeable. Lithium is very good. It can do 3,000 to 5,000 charge cycles before it wears out. The experts about Tesla's not had to replace the battery yet in any car because it wore out. Nissan has, because they don't have the same thermal management. That's the big difference. But the thing is, the experts, and I read this all the time, and they're way smarter than 18 years before Tesla. Before it's like right now, the batteries will probably be very cheap and they'll be a heck of a lot more. I had 85 kilowatt hours in my car, and Now they're making it 100, 120 kilowatt hours. That's 50% increase. And it won't be long before they have 400 or 500 kilowatt hours.
The other question I have, with all these batteries, are they breaking them down then, once they reach their lifetime?
Yes, they're recycling and they're, they're a lot more energy friendly than lead acid. Lead acid is one of the worst. In fact, my car has a lead acid bulb, which is, I don't know why they did that, but it's lithium is a lot more fun. Now, the whole subject of, the whole subject of safety when Tesla, in his first 2 years of experience on the road, I'm talking about big experience. The first car that came out was a Roadster, and it was very small, and they had a lot of problems with brand new cars. But when the Model S came out, they had 2 fires. One was in Sweden, where the charging station had a frayed cord, and it had nothing to do with the car. But it did start a fire, and Tesla, lithium can be dangerous stuff. Once you get a thermal runaway, once you get it hot enough to heat up the next one, it heats up and so on and so forth. It just keeps getting worse and worse, and it's a terrible problem. Once it starts, you can't do it. So that's a problem with it. But the way Tesla got around it, I didn't like it. The way Tesla got around that, they have a little smart battery management system. I mean, I've got 7,018 batteries in my car, 17,007, and they, every single one is mine. And if one starts getting a little bit too much current, the other, or they go a bit too long, or voltage down too much, it's essentially controlled by a series of computers, and it just won't let a fire happen. Okay? So, safety is a real, in the course that I taught, we actually made, for the motorcycle, we used what we call lithium polymer batteries, which come in little bags, and occasionally will remove the control of the helicopters. And they're very light, but they're very dangerous. And so we were always very careful about charging it, just by look. And after I was gone, some of the lab technicians were wondering, oh, I see what the battery is saying. They immediately said, oh, no more lithium, we're not going to teach this anymore. But they tried to bring in the fire department, they didn't know what to do. How you going to put water on this roof? So it is dangerous, but you have to ask the question, compared to what? The other, we talked about the one who started the charging station. The other one happened down someplace in South Africa. I was driving along, a truck came from after, these Mexican trucks that don't pass the city inspections on. And this thing dropped a great big chunk of something off the bottom of the truck. And it fails the bottom of that car. And the little voice inside, you've heard talking to your car, it says, everyone stop the car now, get out quickly. And the car caught fire. And Elon Musk was called before Congress, aren't they dangerous? And he said, we've had 2 Teslas that are, 14,000 we're producing one, and 2 of them caught fire. And did you know in the last hour, 17 pickup trucks alone crashed and burned because the battery used to be there. We store 5-gallon cans of stuff in our house, and I go, wow, it's stupid. That's what we do, because we don't think about it. Gas lines, 1 gallon of gasoline is equivalent to 14.6 9. And there's a lot of power. And yes, electric battery can be dangerous, but if you manage it properly, it can be used. Yes.
Talking about battery. And I see the one here is for 80 years, right?
So the warranty, yes,
80 years, yeah. But if I be careful, let's say I will not go charge, not charge 80% whatever. So, do you have an idea how many years the battery will last?
The battery? Well, like I said a minute ago, the experts that I've been reading say 18 is what you can count on for the age in a Tesla.
18 years?
18 years.
Oh, wow.
Now, there's going to be some that are mistreated or like that, frozen conditions for long period that won't do that. That's what they're saying. Should be that possible. I have Model 3 batteries on the way. I have a solar system on my house that I've got batteries behind my fireplace. have 192 letters to come out of all three. And I charge it up and down, every day. You know, solar is different, it's different. It doesn't have the same, in a car, it's a whole bunch of things, solar homes, for a long time, solar is great. It goes all the way up, comes back, and it comes up, and I've seen no degradation at all. I'm taking the degradation in my car with 100,000 miles in 5 years. When it was brand new, a full charge was 256 miles. I just did it not too long ago, about 2 months ago. You rarely charge 100%, it's not good for the battery. But I did, and it was nothing for free. So I lost 3 months on 100,000 miles. I'm not too disappointed with that.
David, do we have solar panel on your roof?
Yeah.
Or you have Tesla roof?
No, that's a roof. No, you have to have that. We did some work on that. The pickup truck that we built, we actually built solar panels for it.
I saw examples.
Yeah, but the problem is the solar panel, we had to put a trailer on it. The solar panels are huge. You have to put, I don't know, somewhere near 25 solar panels on there, and make one pickup truck work for a little while.
Thank you, Dave. It's been fascinating. I'd like to ask the group to keep us in mind for new topics. We're all open to something of your interest.
Yes, Dave.
Thank you, Dave, for a great presentation.
My pleasure, thank you. I have other topics I want to talk about.
Thanks, everybody.
Did anybody make the electric motor work over here?
Dave?
I realize you don't charge across country.
Fascinating stuff.
The correct answer is yes. When I drive home, it's at 29 miles per hour. 40 amps at 240 volts, 29 miles per hour. When I charge, so if I charge 100 miles, it takes about 4 hours. Okay, and it's not information, I'm getting 120 volts, right? I'm getting 400 volts, 300 amps, and it goes at the rate of 300 miles per hour. So, give or take about 20 minutes. And so you want to have a snack?
It's a little more problematic.
Yes, it is. Yeah, they can't take it back down. They're going towards it before.
Well, no.
You didn't know? Okay.
You have the regular plug. I don't know the number.
My niece and I did it in Florida. Was about 30 years. He was my home there. And the first Tesla I ever saw, the guy on that, I was pretty sure that there was leaking in the glass, and they had that in the storage and so on. He called me one day and said, I got a guy with a Tesla charging at our station. And I said, wow, a Tesla, really? I said, really? I've seen one. He said, want to come in? And I do it. And in our station, you have all kinds of he was taking about 25 units. He said, that's not important number one. Maybe they have to take it go somewhere different.
You mentioned the volt.
Yeah,
Volt or volt?
well,
The hybrids are different. And it doesn't get but I think it doesn't get very much on a charge on the volt. And if you drive an electric vehicle, you're going to be.
not all of them.
No. Oh, on the volt? Why does they work?
Yeah, all some of them.
Oh,
You play an AC with it, you need to make DC with the volts.
right.
So that's so people say,
Yeah.
the other time, my son, he was in BMW. He actually could, he was extreme. It's more electrical than it was gas. The volt was more gas than it was electric. So, in some house, the engine that drives the alternator that gets there's a motor the one dog, and it's very old. And right there, they're on half the year.
Wow.
It's not made for it.
Yeah, that's an interesting point.
But it was.
Yeah.
He drives 25 miles to work, maybe, and if he stops and buses stuff on the way, he can charge it work for free, and he charges them off, so he's happy with it. And they come down and visit us, they take the other.
So, yeah, we're trying to probably unload the lease. We don't want to spend that kind of money. So, the 2017 Bolt was the car of the year. This year. And, so we looked into getting it. A Bolt?
Yeah.
Oh, okay.
You're up here, not the first right, second right, and there's 2 houses with telephones.
Okay.
You guys next door, each got someone there, each got, one got a board, one got something else.
Yeah, you got in the directory. In the directory, it doesn't have you can search for names. They don't have you can search for all your names.
But I think I might have very short down everywhere.
Oh, yeah.
The island is so.
Oh, Did you send me the PowerPoint?
Yeah.
I took a few pictures. Yeah. I'm using it for Kathy. Yes.
You end up regulating all kinds of things about cars. Because look at this, for example, how do I take my disc bill which requires sucks it out of the and so the intake manifold is out and then those are actually over the big guy. And the vacuum assists with the brakes, and that's the reason for the brakes. I want to do that now. Outside of the brakes, that's right. Look at all the I found out that Audi diesel, because the diesel does something like so I found Audi diesel. I removed it from his engine. I put the board on the side. Put it way back to the motor machine, way back to the oh, and that's how I got that. The second thing to worry about is, Bush's model. The second thing is, I have an alternator. I might have a 12-volt battery, but I don't have headlights, radio, everything looks so cool. And my batteries what do I do with it? I think about that. And I said, DC, this even greater. Yeah. One of the guys in a Audi, well, they pull into a level station, and they didn't have it in the program history, so I said, modern power supplies don't use a transformer issue. So if I take a 120-volt AC, this converter is made for more grid, and put my 120-volt AC, power supply and all the others. It works, and that's how I charge my husband. It works like a machine. With no design on it, but we can do it. So that's a third thing. Yeah. I'm going to stop and I'm pretty good. And now I can store it to find out families and find the film. And so my electric water will come out. Turn my compressor and she's doing something. My favorite something. We want to look at this. Or, but I'm on my part, I can read all of it. Makes it all good. drives its suppressor along.
Yeah.
So I don't need to have something good. Yeah, we gotta rethink all this.
The 2017 Ford is costing
But if you go for Tesla, you can buy a Model S, right? If you get one of those bells and whistles, it'll be like 35,000. It's not 4, 5, 6 years old. That's what I would do. Mine was not, but it's good.
a year old. No, 2 years old.
Mine,
Because they had, you buy it, yeah.
I bought it off the floor before that one. The reason I bought it was my daughter was living in and she was inside of, she was all her friends were her. Shop around, so I started looking for Tesla, the ones that were trying to buy one, and they come out with $1. I'm a guy who's sitting off in the and I said, listen, I don't feel like Model X. So we were waiting 2015, and I was over. Would you give me a name and call your vessel and I want to ask some questions about this one. And I want to ask some questions about this one. So I did. And I said, hey, I figured he was from our service. And I thought, I'm not okay. I'm here to learn. I said, is there anything service? And he said, yeah, I'm going to have to. Oh, what's it clear? Oh, yeah.
How far did you go with that?
So, and with delivery, I wanted we had less than so
You know, really stuff. So I was like, take it all there. The lady was so nice. Such a great stuff. I really deserved to be there. When I was there working on, I think they call it the diaper.
Oh, yeah.
Yeah, so some of you were there, I was there. I was like, hey, you? Yeah. Yeah. Of course. You're very welcome.
Thank you, Dave. Great job.
Oh, thank you. Anxious to hear what Stacy has to say.
I think that's